possible also to share your slides, both from the previous session and this one in the same folder, Roberto?
Yes, I was planning to contact with my colleagues about the asset administration shell slides today when I was going to upload mine just after this call.
Thank you, thank you, thank you.
And I will upload theirs too. Okay.
Thank you. Thanks a lot.
Let's start. Can you confirm if you see the presentation?
Yes, of course.
Okay. So let's start. This is the table of content. We prepared some introduction for those who are foreigners to OPCUA to understand the concept. We did some history explaining the classic OPC, which is the first version of OPC standard, and then the unified architecture that gives the name of UA, which is a second version of OPC standard. Then I will talk about the relation with Industry 4.0, some implementations that we can use to implement OPCUA server and clients, and then I will go. These 3 points are more deep for those who are interested in really understanding how it works. Hope it's not too deep or boring. It's just 3 points about the concept in OPCUA, which is the most important, how to address nodes in an OPCUA system, and what are the OPCUA services available, since it is a service-oriented protocol. Then in the middle, I will do a small live demonstration with a server and client, so we can explore all the server and all the details. And finally, I will talk a little bit about the new OPCUA PubSub model and compare it with the most common server client communication model. I will talk about the OPCUA field exchange, which they call FX. I will talk a little bit about OPCUA and 5G. And finally, I will close again with some comments on integration of asset administration shell with OPCUA and a summary of all the links that I was putting on all the presentation. So what is OPCUA? It stands for Open Platform Communications. It's a standard that started to facilitate interoperability in process control and manufacturing automation. So it has the original has a client-server architecture where a client asks a server and the server responds. So in the right side, I draw a very simple example of a common OPCUA communication. We have a server which has a set of nodes that are arranged in an hierarchical structure, and the client can ask for these nodes and understand the tree inside of the OPCUA server. And then after an initial read of the structure, or maybe the client already knows the structure, so it directly asks for a value. So it calls a service to ask for a in this case, for example, for the value of the parameter of the variable motor1 / speed, which would be this one, and the server will respond usually with what they call data value, which is the pair of a timestamp and the value. And with this information, the client shows it in some screen or does whatever other job. So cool things about OPCUA is that the node architecture is extensible. You can add more new data types. It's hierarchical. You can build relations between the different nodes in tree or other types of structures. It's scalable. It started for connecting like industrial computers or PLC, programmable logic controllers, but nowadays it's thought more like to cover all the full stack from small microcontrollers to cloud infrastructure. So it is small enough, its footprint is small enough to fit in a microcontroller. And one of the other cool features related to the project is that has the security embedded in the standard. So when you send a message, you don't encrypt it and then wrap it and pack it on top of OPCUA, but OPCUA integrates the security, which makes it more secure and faster to send the comments. So this is the basic architecture, and the following slides, you can think of this diagram as the base communication situation in OPCUA. So a little bit of history on OPCUA. In 1994, the OPC Foundation is created by these 5 companies: Fisher Rosemont, Rockwell Software, which is a famous automation company, Opto22, Intellution, and Intuitive Technology. And they start working on extending some communication model in Windows, which was called OLE, and trying to adapt it to the industrial situation. And this generated the first standard in 1996 called the OPC standard, that now it is known as the classic OPC. In 2003, because some problems of the classic OPC, new technologies and so on, they started talking about the unified architecture, which gives the name of the UA to adds the surname to the OPC, OPC UA. This tries to improve on top of classic OPC, adding more functionality, but still being backwards compatible with classic OPC. So OPCUA has all the features, or can model all the features of the classic OPC and still has more functionality. And in 2008, it is the release of the first version of OPCUA, which is also known as this standard, which is the IEC 62541. Another important dates I put here is in 2017 was released the latest version of the OPCUA standard, which has the PUF-sub communication, where a server can send data without expecting anyone to receive it or no, which is more like the cloud communications. No, so the normal OPCUA is like a one-to-one communication between the client and the server, and the PUF-sub communication is more like the client subscribes like to topics, and the server publishes information, and they are not involved in who is listening or who is generating data. So it's more like a type of MQTT type of communication. We will see later in detail this type of communication. And this is one of the works from the last years, is to try to move OPC from inside the company to outside the company to the cloud. No? So the OPC Foundation have been pushing this, and in 2022 I attended in November to a conference, and they were probably announcing that OPC UA PUF-sub is now supported by default by the three major cloud providers, Google, Azure, and Amazon. And these are currently the most important foundation members, which are part of the board of directors. So it's Rockwell Automation, which was originally from 1994. Now is ABB, BDMA, which is association for machinery, I think, and it's one of the most important trying to standardize the how to organize the data inside different machines. For example, let's say you have a numerical control machine, so they try to define the nodes, the OPCUA nodes that should go for such a machine, and what methods should have, and so. We have Siemens, Beckhoff, which in the industrial world are known for the automation products like PLC, Honeywell, Mitsubishi, Schneider, and Yokogawa. And I put a picture of the current president of the OPC Foundation, which I think he was working on Beckhoff and related to the original OPCUA specification, and he was, I think, vice president. Now is the president and works giving the lectures on OPCUA around the world. So these are some drawings from the OPCUA Foundation showing how they try to cover all the levels in the factory, from small devices to the cloud, and even in between clouds. So, and one good thing to comment is that they communicate data vertically, for example, from sensors to controllers, and from controllers to the cloud, and so on, but also horizontally. So you can move data between controllers. So this is covering all the swarm type communications, for example, for the Zero Swarm project. So that's why I was always saying that if we use OPCUA in the Zero Swarm, we already are having or supporting a swarm type of architecture. Okay, so this is the original 1996 classic OPC specification. This was, as I said, built on top of Windows, Microsoft technologies. And only could connect Windows devices. And the main specifications are the data access protocol, which is describes the data model and the services to get live data which goes updating every time from the server. OPC alarms and events, which provides a way for the server to notify to from some alarm or event to the client. OPC historical data access, which provides services for the client to read historical data access, not only the most new data like data access, but also old values. Then OPC security, talking about the security on the server side. OPC badge, which extends the OPC data access for being able to manage recipes or sets of actions. And then the others are for connecting, moving XML data and more complex and structured data from server to client. The problems of the classic OPC, well, the classic OPC worked well at that time, but had some problems that arose quickly. For example, it was tied to Microsoft Windows only, so there was a force for companies for being more competitive. They wanted to put OPCUA on embedded devices and so on, so it didn't fit in that sense. Also, technologically, was dependent on the DCOM technology, which was a type of black box from Microsoft, and made a lot of configuration issues and other types of issues. It had low security because it had no security intended, and you had to depend on other securities like the operating system security, firewalls, and so on. So it had no encryption, no access control, and so on. And then, depending on the DCOM technology, made it also very difficult to deal with bugs in the code and delays, because you are always depending on Microsoft. So to try to solve this, they created the OPCUA Unified Architecture, or UPC, the OPC Unified Architecture, or OPCUA, for replacing the classic OPC. So it has the same functional equivalent to the classic OPCUA. So, for example, if we want to convert a classic OPC to an OPCUA server, it's very easy with a standard wrapper, because the OPCUA supports all the functionality from the classic OPC. They moved from this DCOM technology to a server-oriented architecture. So it is operating system and hardware agnostic, because OPCUA only defines a set of services and the data structures that these services should move. So it doesn't. It is not tied to any specific hardware or operating system. And they decided to push for these multi-platform implementations and C, Java, and .NET implementations, but there are many more, as we will see later. Other feature is its scalability. It can work from small embedded microcontrollers to a full cloud-based infrastructure. This is because it has a very small footprint for each node that we add to the server. And in fact, there are from the very beginning implementations in like 64 kilobyte microcontrollers they implemented the full stack of the OPCUA communications. And then, well, multi-threaded, that help the scalability, security. It supports encryption of messages, authentication of users, and auditing. This is I don't know what it is, but these two are cool because encryption is automatically embedded on the protocols on the libraries commonly. So you just activate the encryption and you send the message in the same way. So it's very easy to use. And authentication is also very nice because you can create namespaces inside of the OPCUA tree, and you give different users. You could give access to different namespaces. So, for example, to a worker in the factory, you give access to some nodes on information nodes on the process on the OPCUA node tree. But for example, an administrator of the network can have access to more to other namespaces dedicated to these functions. So in this sense, I think it's very useful for any type of industrial implementation. These are the documents or specific parts that the OPCUA specification has: concept, security model, address space model, services. These first we will see in detail in the following slides. And these I put in blue are the most important that cover the classic OPC functionality. As we see, we have also very important discovery services. For example, clients can search for servers connected in the network. We have the PubSub specification, which is quite new. And then some other specifications which are not finished yet. So the standard is not fully finished yet. What's the connection between OPCUA and Industry 4.0? So OPCUA totally fits with the Industry 4.0 philosophy. And in fact, in April 2015, the Industry 4.0 consortia, which is, I think, mostly formed by German industrial manufacturing companies, they recommended the OPCUA as the best standard to implement the RAMI 4.0 communication layer. So watching at the slides from the asset administration shell the other day, I realized that the asset administration shell is also recommended for the communication layer. In this sense, I think OPCUA and asset administration shell overlap a little bit in this layer. OPCUA would be on the bottom, explaining how to exchange data, and also has this data model, which overlaps a little bit with the data model of the asset administration shell, but I think they are compatible. And then asset administration shell goes a little bit higher, defining the structure of this, the basic structure of an asset, to describe an asset. Okay, OPCUA implementations. Because the standard only describes the data model and the different services or packages of data that are sent from client to server. And these implementations really give a practical implementation of the OPCUA. So typically they have interfaces like creating a server, adding a node to a server, adding relations between nodes. So they give you this type of functions to easily create and manage OPCUA server or client. I put here on the top the open source implementations. I think the best one is the Open62541 library, which is implemented in C. And this is the one we use on our C++ edge computing library, which we will made open source during the Zero Swarm project. And we like of this is that the library has very good documentation, also works pretty well. We didn't find any bugs on the library. And the problem is a little bit harder to learn, but once you understand it, is also easy. Then we have also the free OPCUA project. This is, I think, not so professional. I think in the first one there is involved people from big companies like Siemens, and there is like 80 people in the repository, something like that. And this one is more, I would say, amateur, because it's only 7 people there. Has bugs. The performance is not so good as the other, and also I think the interface of the API they created is not so good as the first one. But nevertheless, it is very easy to use, and they have a C++ client and server, and also a Python client and server. This makes it like the best option, I think, for a starter, because in very few lines, like 10 lines, you are having a fully working Python OPCUA server. Other good thing is they have a Python graphical interface client, which I will use in the demonstration today to access a server and explore it. And also they have a graphical interface to create the structure of a server into XML. So you have different options to create the server. You can create it from the code, calling, for example, add node function, or you can just describe using this graphical interface and XML, and then you just create the server and load the XML, and the library automatically creates the full server structure. Then you have another implementation, so in JavaScript and Node.js. And also the OPC Foundation themselves have a .NET implementation, which is also open source. And then proprietary solutions, we have tens or maybe even hundreds of them. I put these two here. This is one of the most famous from the company Unified Automation. They have a full implementation of the client-server model communication and the PubSub model communication. And I like their website because it explains with very good explanation and diagrams how OPCUA works. So I've learned a lot of OPC in their website. And then also Process, for example, other famous company has the same. So they sell you like a library, maybe it's better than the other ones, but from my point of view, after using the Open62541, I don't see any need for other library. And I put here a link of a repository with a full explanation of a full collection of the implementations. So maybe, for example, you want a Ruby, another language implementation, MATLAB implementation, you can go to this link and explore there. Maybe you find a project that fits your needs better. So let's start with more deep dive. Yeah.
Is it possible to maybe stop 1 minute here before digging deeper to the nodes and getting more let's say, our hands dirty, just at the theoretical part, just to see if there is some questions. I mean,
Yes.
I have one that I would like. So if you go back to the previous slide. So just let me see if the others might want to first ask any questions so far. If not, I might ask one question.
I have one question, may I?
Yes, please go ahead.
Yeah, so what is the relationship between the OPC and, for example, the transport? I mean, for example, TSN as a transport. Is that represented as one feature in the OPC data structure of the devices, or how is it?
The common OPCUA goes on top of the TCP IP stack. So there are packages inside this normal internet communications. And then there are, I will talk at the end for the OPC FX, which is formerly was called OPCUA over TSN. This is this modifies the transport and also they are working with the 5G also in the same way. Instead of using the TCP stack, so they modify the lower layers so they can achieve repeatability, no, a fixed latency in the communication.
Just maybe, I mean, because my question is also similar to what Jose asked, maybe just for some clarification and better understand. It's not a question necessarily to Roberto, and I would encourage our colleagues with background on network to help me a bit on that. So if we go back to one slide, the one that you show the RAMI 4.0 picture. So from what I understand, and probably please, Jose, let's say Andre, Giovanni, at least those guys that I see also from the let's say telecommunications. My understanding is like first of all, OPCUA covers a bigger picture than just let's say control to device or device to device communication. Given that probably for us telecom people, this would be more like an application layer on top, right? So it's more like sitting on layer 7 of OSI model, and then in majority of the cases, probably the network, either being a wired network or a wireless network, doesn't need to do much. It just like needs to transport the packet. Probably
Yes.
the hard requirements comes when it goes to the scenarios that you have control to control or control to device or either device to device. Then you might need to consider this time-sensitive networking, as has been mentioned. And then I think what Jose asked is quite important, like how OPCUA tries to dictate or interact or somehow modify, or I don't know, whatever with the transport layer down to dictate this packet needs to be reached to X device within this blah blah, I don't know, downtime, or if it doesn't reach before that, this would not work. So something like
in the as you said, the common OPCUA is in the OSI model is application.
exactly.
Can I suggest the link,
Yes,
please? So can you hear?
Yes, please. Yes, please.
So it's one of the links which is in the chat. The second one, please. If you would open that one.
Yeah, the FX, no?
Yes, that's exactly a drawing there. So if you can open that one and share it, that would be nice.
Yeah, I am opening. Yeah, this I will talk at the end about the FX and the 5G.
Yes, scroll down a little bit. Yeah, thank you. So the point is what it was discussed up till now, and you see the layer. I don't want to call it. If you want to call the application layer all the layers which exist here, you are free to call them like that. Let's say the data transport communication, the data transport level is quite low in this point. Yeah. So there are various mappings which are defined in the OPCUA for those protocols which you can see there, client server and pub sub. either to TCP/IP, mostly client server, either to UDP/IP, mostly pub sub, either even to layer 2, mostly pub sub, either to MQTT or to AMQP for communication over the cloud, client server communication or pub sub communication over the cloud. You see then the security points which Roberto was showing them very well. You see also the common OPCUA models which he was mentioning, and we built up several layers above those ones, even with regards to functional safety. And with the yellow one, we started to do OPCUA fixed motion, and Roberto will show them probably in a while. And over those ones, it comes companion models. You know that there are companion specification for powertrain, for pumps, for robotics, for plastic molding, and so on. All that are adding up, let's say, object types, which exact now Roberto is going to show. And vendors can even extend those ones. So,
sorry, Marius, I'm a bit lost. I know that maybe the words that you're using, it's very much easy for you and guys with the similar background to understand. But can we go a bit step by step, at least for me to understand it? That
yes,
I got the point. So it's just like, so let's put it I'm talking about the bottom two, so the yellow box below and the blue box above. So use case specific mapping to protocol and physical layer. So I understood that there is some sort of mapping that is happening between what is happening on top and TCP/IP, UDP/IP, as you mentioned it in the POP/SOP, direct layer 2, so on and so forth. But first question, what does this mapping mean and how deep it is? Is it like to set some TCP/IP, let's say, rules, or at what level this mapping, or is there any reference that we can double check these mappings and see how this would translate to the telecommunication world? Because it's still TCP/IP, and these guys are, if I'm not wrong, is layer 4, so it's not really down basically yet in the OSI model.
Yeah. So the point is mostly it's the packet structure or packet or frame structure, if you want.
Frame structure, okay.
The payload structure, how the payload looks like.
Okay.
And also there are more security aspects also to be considered also in these mappings. There are JSON mappings and other and so on. So
but it doesn't like enforce any I don't know, like for example, packet drop rate. This does not dictate any packet drop rate, for example.
Not as far
sorry?
Not as far as I know.
Okay, but I don't know if it's possible to share with us maybe a link that we can dig deeper here to
yes. And I think maybe Roberto has it already. So above there is a link on the reference reference OPCUA foundation website.
Okay.
And there is only on the security, but you can just take the beginning of it. And if you can share it, maybe, Roberto, just reference opcua.org. So let me try to put it here in the chat.
Yeah, thanks a lot.
Can you access that one, please?
Let me just double check. So, okay, let me just.
I'm opening.
The last one, yeah.
All right, thanks.
Yeah, exactly. So there you have all these ones. Now, a little bit of an issue with that is that the search doesn't always work very good.
Okay.
Oh, it works the search, but when you click on the result, it doesn't give you an error. I don't know what it means.
I understand.
So you need to go on the main table.
These are the effects, no?
Yeah, this is the published FX. So here you're finding all the published OPCUA base specifications, companion specifications, and all of that. So I understand it was a big work. It's still not working perfectly. We are excusing ourselves from the OPC Foundation perspective, but yeah. So but you find a little bit of all this information. At least from the table of contents, you can browse it very well.
Yeah.
Yeah. The first group is the one I was showing in the presentation. Is all of this.
Okay. Yeah.
This is the basic OPCUA route that was started on 2008, and is what is called the OPCUA specification. And then they have the FX additions, which is the field exchange with this for sure talks about the transfer layer. It's not only packages on the application layer, like the common OPCUA. And then also there is a group working on the 5G, which is quite new. But I will talk about this in the end. I wanted at the beginning just the common client server, so it's easy to understand, and then move to the
And if I may just have another question before you move on, in the previous picture, not the last one, the one with yellow and blue, just for me to understand another word that Marius used.
It's on the slide, I think, or
the link. It was a website link with the
the link.
Yeah, the link. Yes. It was that picture. So and as far as I understood this, so this FX is like this yellow part below that, as we spoke. So they are starting working also on 5G, and there is a part related to TSN, and then here you mentioned that there are some generic, let's say, kind of. Let's say, how can I say it, like settings, and there are some companion which is particular for some devices or objects that would be in the field, right? So it's like OPCUA does a generic, let's say,
The OPCUA over TSN is the same as the FX.
Yes and no. Let's put it like that. So let me try to answer to Puria's question here. So let's go a little above. So you are talking about mappings to protocols. Then already Roberto showed what kind of mechanisms of data exchange are pub, sub, and client server. He talked a bit security. Now OPCUA meta model. OPCUA meta model is exactly what Roberto has started to show, and you said it goes a little bit into the depth. This is the way that OPCUA everything is in OPCUA everything is an object. Yeah. So this is taken from the object-oriented programming, and we wanted to create this kind of very base layer. So imagine again like a Lego system, right? So in a Lego you have some bases, some pieces which are going in all sorts of setups and constructs which you want to do. And there are some specific ones. Well, those basic ones are the meta model, which was shown, which Roberto will show probably in the next slides. And that's that layer. Is there any question to that?
No, I think I understand that. So it's just like to kind of a generic philosophy of this Lego modeling, let's say, yeah.
Correct. And then based on that, we said, well, let's make some constructs already, because okay, everything is an object, doesn't help me too much, and all the nodes are objects and this and that. There are different node types and so on. Great, but I would like to use it for something. So I already start going in the direction. Let's put, I don't want to give just as an example, like .NET or C# and so on, or Java. So, all this kind of conceptual thing. Okay, let's not make just very simple object like in C or C++. Yeah. Let's make something a little bit more, some constructs which somebody can use in their information modeling. So then they came up with the common OPCUA models. And these are, let's say, what is called core object types. And you will find there various data types, various constructs which you need in object-oriented programming, and you need to represent your reality and so on and so forth. Is it clear?
Yeah, I think it's clear. Yeah. Okay,
so
but
you can think
because I'm just like thinking. I understand the value of what you explained from the perspective of, let's say, managing a factory shop floor, and that's the main purpose of this. What I'm struggling to understand is like how this object-oriented philosophy, or let's say everything that we're speaking, could expose anything on the transport layer below. So this is my main reason, but probably we can stop here. You can continue.
Let's go to that. Let's go again, maybe to that drawing again, to the website drawing, to the architecture, stack architecture, if you can, Roberto, please. Yes, thank you very much. Well, all that is part either of common OPCUA model. So if you consider the pub sub, they have already some models which are added in, and the base network model, which are now also extending the common OPCUA models. they have some representations of the network interface of one Ethernet port.
Okay.
So on. So where you have, let's say, like in a class, you know the class there, you define the class or a structure if you want, and in the structure or in the class you have some kind of components, and some of those components are related to exactly what you pointed out, to features related to, in general, we took them from the IETF or from the IEEE, so we didn't just invent something new. And we said, okay, then I have some kind of feature in terms of what kind of bandwidth is supported and so forth. So what kind of media type it is and so on.
Okay.
All these kind of things about what could you imagine that an Ethernet interface is being described. Now, we don't want in OPC Foundation to succeed ourselves to IETF or to IEEE and say, guys, you don't know anything, we do it here too, or we copy exactly everything what you took and you created during the years and move it in OPCUA now. No, the point is not that. Because why is not that? Because there are exactly other existing mechanisms and we don't want to necessarily disturb those ones. We would like to be able to read this data in OPCUA and to see this kind of information. We don't necessarily want to configure the Ethernet interface.
Okay. Okay. I mean, this is very important that you're saying. So basically, the intention is basically to read what the transport is offering you rather than configuring it.
Yes, because the
Okay.
fight was with Profinet and with CC-Link and with Ethernet IP and so on. And they said, but then you move everything into OPCUA. And then we said, okay, no, we should have a layer which is like netconf or SNMP if you want, a little bit old-fashioned. But now we are going everywhere in netconf YANG models. And we say that one is the layer which configures the Ethernet interface. OPCUA shows just some aspects from it, which we discussed in the working groups. It makes sense to be taken over and shown into OPCUA object types.
Okay. But and the same philosophy eventually should apply to the 5G with the same philosophy, because you don't want to configure, you want just to read them from. Okay.
Yes.
Okay, that's great. Thank you. I mean, it's
So Marius, is it so then that there's no any linkage between, for example, the OPC UA client and, for example, the CNC or the CUC, right?
Okay, wait, that's not that you go a bit far here, because the OPCUA can require a given quality of service. So you can also have object types, and some of them, they are defined in pub/sub over TSN specification, now included with the part 14. Some additional ones are included with the base network model, included now with common OPCUA models. And some additional ones are included with OPCUA FX. That's why I'm saying that pub/sub and FX is not exactly the same thing. So there are a little bit of additions. So from the OPCUA, from the application layer, you can ask for a given quality of service. You can say that I have this kind of needs, and I would like that this kind of needs of communication should be satisfied. So you can require that kind of thing. You need a sort of in-between layer where this is called CUC very often. Middleware, you can call it like that. Now in the 6802, we call it like that, or CUC in the IEEE perspective. And that one transforms your requests coming from an OPCUA server to some kind of a connection manager or something like that. This is like a CUC, and that one is able to transform the data into information to be required from a CNC, from a TSN CNC. The TSN CNC replies with its known mechanisms, netconf or something, and that CUC needs to transform it back and reply it back to the initial OPCUA server requiring that quality of service.
Okay.
So basically there's like interface or like a basic netconf between the OPC UA and the CNC, for example.
Yes.
Okay.
We can look on that a little bit in a more deeper meeting or something like that. It's the thing is I'm not able to share that kind of. We have nice drawings, but it's in the IEEE APPI IEC 6802 TSM for industrial automation specification, and I'm not really able to share with everyone, so we need to see how we do that. I can do it. I can show it in other drawings if you want, but I don't have them now in this section.
Yeah, perfect. I think, I mean, that answers a lot of questions, and it was wonderful. I think this is quite an interesting information. So perfect. Thanks a lot. And then probably we can take it up in another discussion to check how to not merge, but to see how standardization gaps could be fulfilled.
Yeah,
Okay,
and then Purya, you're asking about vendor specific and companion models and so on.
Yes.
So with time, we wanted to even extend, and we said, let's create object types which are specific to plastic molding or to robotics or to mining or to pumps or something like that, or to device integration and so on, generic devices. And then we created this work groups too. And then over those ones, maybe in a company you think, yeah, but that's not enough because I have something more. And we do it in our company. We'd see that there are some things which are not yet covered. And then you extend those ones, because the wish with OPCUA, also then for the layer of communication with TSN and with 5G and or cellular communication, is not to have just different forms of the equipment and colors.
Correct.
It's to have also the own values for each company. So therefore you have a higher layer which adds on value for each company.
All right. Thanks a lot.
These are some of those, no? Like plastic, rubber, machine vision.
Yeah. These are those companion pumps. Yes. Exactly. You see how many they are.
All right. Thanks a lot. I mean,
this is just on. This is even on top of as administration cell is like defining the structure of the tree and the name of the variables there.
The asset administration shell is yet one more companion-like specification. So it's something like these ones. So it's is in parallel on that stack architecture view which you showed before. Yeah.
All right. Thanks a lot. Thank you. Much clearer. Thank you.
Yeah, thank you, because I'm more on the object modeling part, and I'm not. I was not going to be able to explain this underlying communication stuff. So for me, it's also very, very useful how it integrates with other protocols different than TCP/IP stack. Okay, if there are no more questions, I keep with the presentation.
Yes, please go on.
Okay. Okay, so I just wanted to show the basic for you to understand how the meta model of OPCUA, and the most important is the concept is the OPCUA node. So everything in the any data in the OPCUA protocol is described as an OPCUA node, and this node has only two things: attributes and references. Attributes are fixed and depending on the node class. So you can see here a tree of nodes. You have some objects created by me, but also here you have data types described on the tree itself. So you can link, for example, I can link this Boolean, link it with a reference to Boolean. So this is the purpose of the reference. So, okay, I will start again because I made it very, very complex. But each node has attributes which are fixed. It's a fixed data structure in the memory defined by the OPCUA, but it's different depending on the node class. The node classes are also 8 and are specified by the OPCUA. So, for example, it's different, the attributes for a node like a bool that contains a value, and then, for example, this, which is like a folder object container, which is of type object. And then we have the reference. The second part is the reference, which is a list of links from one node, which is the parent, to some children. And reference have types, which are already the standard defines a set of types, but you can also extend. So the types gives the meaning to the relation between these two nodes. For example, you can have a reference of type has type definition. That means that this object node has a type definition, which is in this case is a folder. So in this sense, I explain it is a folder. So the program knows this is a folder, and he, for example, puts this folder icon. This is the way he knows that he should put a folder icon, because I'm giving this extra high level information to the node, adding this reference. Or, for example, has reference of type organizes, which just creates a hierarchical connection. So in this way, the program knows that he should print this test bool inside the booleans folder. So this is the basics of OPCUA. Attributes contain some properties and sometimes also the data of the node, and the references creates relations in between the nodes. So it's very, with this type of architecture, you can create very complex objects, adding different layers, and you don't have to create a tree structure. You could create any type of data model you want, not only a hierarchical tree, because with the reference you can create connections between nodes. You can create your own references, or it's even possible to reference nodes in other servers, in different devices. So in this sense, OPCUA is very configurable and expandable, because you can add your own data types or even reference types to the system, including them in the node tree. So as I said, the attributes are dependent on the node class. This is the content that goes in memory. So for each node, you are using more or less this memory in the system. And these are the 8 node classes defined by the OPCUA specification, which are variable, method, which is to execute some function in the server side. For example, the client executes a method in the server. For example, for a camera system, for example, to take a picture, for example. Object is the type I showed before, another class object, just to contain another objects or variables. And then we have types. We have object type, variable type, and data type, which are in this area of the tree and enable the connection with reference of has type definition. And yeah, we have view. This I don't understand. So we can see here in the OPCUA client, we can see the node class is also one attribute of the node, that it can be read. And for example, here we have a variable. Here we had an object, doesn't have data, but this is a data value, has this value section in their attributes, and it has a server timestamp, source timestamp, it's not read here, and then the value itself. So this true is the value, the Boolean value that we are holding with this node. So any client can connect and ask for the value it would get in this moment of time a true. Regarding the references, the reference types are also stored like the high-level types in the tree, and the standard defines a set of reference types which can be used to create references. So in the case of the library I use, they define a fixed locations in the tree for these reference types, so they are easier to decode and locate. And finally, the address space. I wanted to talk about this. How to identify the node. So each node in the system has a unique node ID in the tree, which is composed by a namespace index. We can have, as I said before, different namespaces to slice the nodes into like groups. So the types always are in the namespace index 0 commonly, and you put your objects in the namespace 1. And the ID has the namespace index, identifier type, because we have 4 ways to identify the node. We can have a numeric value, which is the easiest one. For example, this one has a numeric value of 53,000 something. We could have a string, which is the old way of in the classic OPC. For example, this one. And we have this global unique identifier and opaque values, which are other ways to identify it. And then finally, the identifier itself. So, for example, for this node, the namespace index is 1, which is specified here. Identifier type is a numeric value, which is this I, and the identifier is this 53,000. With this, we can find any node in the tree. So I commonly use the numeric value because it's the faster to decode. It's faster to decode than the string ones that must compare the full string. And this is a way the software libraries represent a node ID in a compact way. So they have namespace equal to namespace index, here the one, and identifier type. They use these common letters to do the identification of the identifier type, and finally the identifier itself. Last of this more in-depth OPCUA explanation, I wanted you to know the services of the common OPCUA, so you understand really what how the system works. Because what OPCUA does is to define the data structures that must be sent through the different services. So, for example, the client has the following services: discovery, to look for servers in the network. So the specification defines the package to discover and the answer that the client may get. Read services, where you specify what nodes you want to read, and the standard also specifies how the response is structured. So the response has information like if the node could be read, the value of the node, and so on. And the standard specifies exactly the data structures that the response should have. You have write, history read, history update to read history, service call to execute a method in the server, browse, so it's a service you can use to ask the server the structure. For example, you can ask the server the root, and from the root you can ask children, and it will give you motor and motor 1 and motor 2. And then for each motor you can ask children, and it will tell you temperature and speed, and so on. And then you can also register new nodes. And in the server, in the same way, it has some discovery services to read and write nodes. It's also done with the common services like the client. Yeah, and they have node addition and reference addition and deletion to create the structure of the server. So now I wanted to do a very easy live demonstration. I have here the same server you are watching here. it's running. It's publishing a boolean, an image, a float, and an integer 32. So this is the free OPCUA client, and now I am connecting to this is the IP. In this case, I put localhost, but if it's remote, I only have to change this field, and it connects. We can see types and objects folder. So we add our objects in the object section. When you create a server with the library we used, this is already filled with the standard types. So here we have the basic types. So we have this is the types basic. Yeah, so here we have some standard types. For example, the folder type, I took it from here. And then you create your server is an edge folder that contains 3 more folders, and inside there are these objects. So if I click here, yeah, I can see all the attributes and references of each node. For example, this is a folder, has this small set of attributes, and then the reference type folder, and organize, which is the set of children that has, which is in this case has the relation of children with testable. And for example, this one has 2 because has 2 elements inside. And then just to show you, because natively I don't know, this program is a little bit bad.
Maybe meantime, we can take the comment from Marius. So could you please?
Small point here. So all the representation of those object types and their instances, because you create object types exactly like in OPCUA is, or in the object-oriented programming, you create object types for things from the reality you want to represent and their components, as Roberto showed. And then you need to instantiate them, because you may have several instances of those ones in your OPCUA running server. What exactly Roberto is showing now. So if you open the types there, Roberto, you'll see even more than just these objects and so on. So you'll see all these object types which you have used and so on. And yeah, so that's the, let's say, the point. And then what? Yeah, you have exactly the various object types. You can, if you open object types, for example. Yeah, you can open object types, and then if you have base object type, you see how many object types you have here. So you instantiate in your OPCUA, server those ones. But all these things are represented in an object in a file type called node set, and I put the link there to how the node set is structured. And exactly with all these references. So basically, the nodes in the node set are just a list of references, one referencing to each other, to another, let's say there. So this is the way you represent it, and there is an XML schema for that. And yeah, and there are XML schemas then for various specifications, because once you do a specification, you don't just list the object types which you created for that one. You also add, let's say, the node set. That means the XML schema for that specification, so that a client can use it and the server can also reference it easily.
All right, so maybe I can ask, so if you go please to the object types, let me see if I think I'm grasping something, but probably I have much more better understanding now, definitely. But again, because probably I'm struggling. So if you open the base object type,
Yeah, that's the base one. Everything is
so
derived.
here you have like even one is connection. What is it like? Connection transport type.
Yeah, for example, yeah. You can
Okay.
open that one. Yeah, open that one. That, for example, datagram connection. Or yeah, you don't have extremely much. So you see, you have just network interface here, Purias. But
Okay, so here they're just like okay.
try to find you another one, which is maybe more for what you wanted to have. Let me just try to look on that. Just give me a second. Yeah, for example, this one, if you open the link which I'm putting in the chat now, please. Because yeah, exactly, you want to do quality of service configuration, so it's kind of telling you here how the publisher subscriber works and so on. You have there middleware and so on, and you see here all these layers, actually how the layers are being crossed. So and then you can look on the, for example, on one of, if you scroll down at some point, you can scroll even a bit down, and then you can go to transport settings. You see pops up connections, and you go to transport settings. And well, okay, then this doesn't work because probably this is one of the problems of the thing. Here, just a second. Transport settings. Try to find the right one. I'm just trying to find you a good example.
Okay.
Even this picture is quite interesting. I would say.
Yeah. So, or yeah, quality of service category. I'm just trying to find one of these which works. Okay, just click then on quality of service category. A bit below, yeah. And yeah, there are various types of categories there and so on, and yeah, let's to find the right table for it. There are some priorities, so there are, it's a lot of, you need to spend quite some time, because when we created these object types and so on, there are always somebody coming with a improvement, and then coming with an improvement. How it works, you don't modify existing object types, you add new ones, you extend for existing ones with new ones following that workout and so on. So probably you may need to go around in the specification and try to find the right place and the right values and so on.
Yeah, but thanks a lot. I mean, this is already fantastic. So I'm getting a better understanding from the general perspective of OPCUA, and now how this also maps to the below layer, let's say the transport, and probably we can double check that if it's needed to even to change anything on the say 5G world for that. But so far so good. I mean, I definitely I see a huge value on adaptation of this technology in Industry 4.0, and then the mapping and everything. So probably yeah, we need to. I mean, for now I have some homework to do, so I need to read a bit, digest what we have discussed, and then come back. But I think we are in a correct path, because this is one of the objectives of the project. I think if we can help each other to push in different directions, 3GPP or maybe OPCUA Foundation, to kind of find some common places. It's one of the objectives of the project indeed. Well, thank you very much. I mean, so far so good. Thank you very much. I have much better understanding.
And now, if you give an example, what I believe for 5G should be done, if you click on the last link, please, what I sent.
Yes, I'm going. This?
Yes, exactly. This is the part 22, so base network model, which extends the OPCUA base object model with some object types, and you see here the
I lost communication.
Yeah, me too. I mean, I was wondering if it's only me.
Marius said. Now, yes, but we lost you for 10 seconds or so.
Yeah, sorry. Seemingly some internet connection. Yeah, so you see here that we created a list of interface types. Interface notion in OPCUA is used to implement the notion of multiple inheritance. And you can, for example, open whatever their IETF-based network interface type so that somebody from the networking sees it. So you see here you have the admin status, opera status, physical address, and speed. For example, this is what we put as features. So I believe that for 5G you need to do the same and to create
Exactly.
kind of object types. What are those ones? Maybe Andre or somebody can already comment. Maybe somebody already started to define them in the 5G CIA or something like that. I don't know where is that work currently.
Yeah, Andre, could you, as far as I know, I mean, I think their understanding is a bit ICT driven, which was probably coming from the initial comment also from Jose, and I was coming from that background basically. But now I see it a bit different. I don't know, Andre, do you think that they, in 5G ACIA, they're seeing the situation like this one, or they have a more ICT driven perspective?
Now, okay, let's say 2 weeks ago, they have joint workshop between OPCUA and 5G CIA when they tried to clarify these some questions about quality of service in OPCUA and OPC and 5G CIA. But okay, they did some steps here towards synergy, but I would say so far it's at very high level. So still there are no specific solutions or even specific approach. What we discussed here, I would say much more specific. What they so far have been considered. So
Okay, so it's just incipient for now. Okay, so the outcome has to be that one, dear colleagues. So that has to be this is specification. This stays written in the spec if you want. Also, exactly as you see it's here. So that needs to be. So probably what we can do, we can use these models and so on, extend them. We cannot change them. We cannot change them. We need to extend them with something. And then somebody needs to go in the 5G CIA and there and make a proposal there and discuss, see what the other companies are saying. It's probably that's going to be changed. I'm not guaranteed that it goes exactly like that, unless it's very, very, very strong motivated, and so on. And yeah, that's how it should work. Otherwise,
yeah. One option is.
Sorry.
Sorry, please go ahead. But
yeah. So I mean, because probably we are a bit biased by the 5G or 3GPP. So in this case, this model is. I mean, I understand that it's trying to model this Ethernet as a transport, but then it's quite generic in the sense that how we can then model, for example, the TSM part, like there's AO2 QVB functionality with different priorities and delays, because it says that the speed and then some data string. So I mean I mean this requires extending like new more specific
can you hit back?
details on
Exactly. Exactly. Thank you, Jose, for this question. So can you hit back here? Exactly, Roberto, hit back there once. And you see here you have IEEE TSN interface configuration type, ESN, IEEE ESN, TSN traffic specification type. You see, you have several ones. It's not everything. Again, we don't want to configure everything from the OPCUA perspective, because again, we got into trouble with the other, if you want, players in the industrial automation field buses, saying, but I have also some equipment there, and then the system integrator will say, and then they'll say, yeah, but then you want to control everything from OPCUA, you cannot. So then you need to use Netcom for that. What you can do is you can read, you can set up requests. I have this kind of, I have this maximum interval between my frames. I want to have, I don't know what. And then you can read what the CNC is configuring you. For example, it's configuring you what kind of stream names you have, what kind of stream IDs you have, and so on. So that you can do. Otherwise,
I think just building up on what Mario said, and if could you please just put this this previous picture that we had with the transport picture?
okay.
Yeah,
Then you have to go back in the chat, and it's the second link. I think. Yeah, that's one. Yeah.
yeah, exactly. Not this one. The one that was with the transport.
The one with
I tried to share the link here in the chat. I think probably it's not getting there.
I've lost this.
The one that is with reference
it's
OPCUA.org.
5454. If you checked in the chat,
Exactly.
it's 5454 the chapter. So
Exactly this one.
yeah,
So if you go down, so maybe just building up on both Jose's comment and Mario's comment, I think, I mean, maybe Andre could also correct me. Let me again come back to the 3GPP word to give you an this is my personal perception. Maybe it's wrong. So when 3GPP wanted to incorporate TSN, what they did not necessarily change the native part of 5G. Instead, they introduced some translators in different fronts that plays the correct, let's say, translation between the IEEE TSN to the 5G world and then get it back, right? I think what they are trying to do now in this world basically is to find another translator out of the end station from the QS category to something outside, right? So it would be a new unit, new entity. And this one does the translation and communicates with the transport, the routers of layer 3 or bridges. It could be, so this is the network part, right? So this could be 5G, let's say network, or it could be some wired network. So there could be a new external translator between these QoS categories in OPCUA to something outside. That outside communicates with the network, let's say manager or whatever, and then the configuration to the network happens by that, let's say, whatever solution that the network applies. It could be SNMP or whatever, netconf or whatever, right? Yeah. So I think probably it also makes sense because it preserves the word of OPCUA as it is. It creates just a proper interface. It makes a standardization easier, so on and so forth. Yeah. At least this is my understanding. Probably it would be nice to build on top of this picture, extending it a bit and reflect on this idea and see where we can contribute.
Very good. That's it.
One question. This we are talking about is at the standard level, not to share between at the standard level, but anyway, you could build your own implementation, no? And for example,
exactly, this is
modify some node you want to really modify some parameter. This is the implementation of the server side, and you could do it if you want. Yeah, but exactly. Only for you, no?
Yeah, yes. Correct. But sorry, if it's at the proof of concept level to show that such an external translator works, we can try to do an implementation to show that something like this might work. Yes. But later on it needs to be harmonized.
Yes, and then you have a very convincing argument in the 5G and OPCUA work group to go there and say, hey, we did this modeling. Actually, we use this and that object type from part 14 for part 22, from this, from that. We extend it a little bit with something, and we did this implementation. It works like that. And look how I changed the parameters, and look how you can read it in the OPCUA client, how the parameters have changed if I change something in the 5G or cellular network configurator and so on. So if you do that and it shows in the nice way, and this is also coming from 3GPP, so it's not a totally different name which somebody invents just in our group here. It's taken from the 3GPP specification and so on. I think nobody will complain. It's just congratulations.
Maybe a question to Jose, Andre, and my colleague with a better knowledge on 3G. But I'm a bit struggling to find a host for that translator in one of the essays of 3GPP. Would you think that this would be part of SA2 picture? Would it be considered as a kind of translator for QoS? How do you see it?
I think, okay, it's again, so Purya, what we discussed before, it can be like two alternatives, so two models. If it's about TSN model, so then probably it should be like CNC. that talks somehow with 5G quality of service rules and then impacts on this 5G as TSN breach. So,
Correct.
so this CNC and the quality of service rules are involved. If it's about 5G native, so probably somehow 5G exposure should be involved. This exposure function should be involved, and again,
like SA6.
with 5G quality of service rules. So,
Okay. So it goes to SA6 probably, right?
no, I think it's still covered by
SA2.
SA2, but it's not in current specifications. Yeah. So
Yeah, correct. So
but
that's why I'm saying if there is a gap. It's a gap. I mean, I think
it's a gap. Yeah, and maybe we can talk with our SA2 delegates, this Chenkwa. Yeah. So
yeah.
to maybe to push somehow to release 18 or 19. So
Correct.
okay, they define TSN, but then okay, we have this gap. Then how to map this quality of service? Okay, if there are like two, and there are two options. Yeah, for each of options, it's need to be solved. So
Correct. All right. So I think, I mean, this could be a point that maybe we can further discuss with Marius and Jose when they are in Stockholm. So I
Yes.
see also
because
Daniel.
Chenkwa will also do presentation there.
Exactly.
Yes, about
Yeah, exactly.
19 gaps, and then okay, we can clarify with him, and then yeah.
Correct.
One quick comment.
Yes, please.
Uri, Andre, I was thinking that maybe there is even a simpler step where, like in this case, where you end up setting the SCP codes, you don't do anything in the network. You're basically only talking to your end host to mark the packets, and then you assume that the SCP support in the network is already there. So in 5G, we could have like a network with multiple APNs or multiple slices with some QCIs that are predefined, and then basically what the OPCUA would be is to interacting somehow with your connection manager in your device, so that there is a classifier there in your modem, so that I don't know exactly what, but this particular object with this priority label is then treated or classified into the slice or the APN that corresponds. So I just want to bring the point that I think having these interact with the network, so the network sets up the QoS, it's a complex case, or maybe even a simpler case where you don't need to explicitly talk to the network, but you just need to interact with your connection manager in your own device. Maybe that could work in
I think you have also a point here, but probably let's put it like that. Probably what we were discussing before was more like to provision a new setup, while here is more if there is some let's say quality of service available in a 5G transport, like as a menu, and then how the traffic can come and interact with that menu of available QI, and then go directly to the correct one. This is also another important angle. So I think this is also, I'm not sure if this gap is already covered. I mean, probably not. This needs to be also checked. And then it's very good. Yeah, thanks.
Yeah, great discussion. So this is exactly this, Daniel. Thank you. So very good discussion. This is exactly the points which we need to discuss in order to see how what is, first of all, what are some parameters, what should be shown in the OPCUA model, and then we can add something. And then if we would be able to showcase that into something, that would be fantastic also.
Excellent. So Danny, then I keep you also in the loop because the guys are coming next week for a North Node workshop, so we will have them in place, but I will keep you also informed. We can maybe check and continue working on that together, okay?
Puri, I think it's over next week.
All right. Yeah, exactly. It's next week. Yeah,
over next week, yes.
Over next week. Yeah. Sorry, I'm mixing it up with my travel too. So I'm going a bit earlier. Yeah, they are coming in 2 weeks' time to Stockholm. Yeah, exactly. So thanks a lot. I think, I mean, it's a super fruitful conversation. Thanks.
Okay, should I keep the presentation, or do you want
Yes,
to?
please continue with the presentation. Sorry for the interruptions.
No, I think it's good that the discussions open more natural than in the end, so it's better. I think we are on time because only a few slides away from the finish. So I will just a few comments that arose regarding the data model. So because Puria, you said you didn't fully understand yet maybe the concept, but the cool thing is that you add your own data types here and your own reference types. So you can describe a complex object, for example, a network connection, and then in your server just instantiate one object of this type, and then you get like all the tree already constructed and maybe connected to the functions underneath that do actual change on the device side.
I understand this concept now much better. So basically, you have a sort of a template, a blueprint that you just instantiate in the server side, and then you start to customize it based on your need of actual deployment. If I understood that correctly.
Yeah, actually, you create your object types first. You create your object types first, and then which you extend existing ones, and you do it in a customized way if you want, as you called it, and so on. And then you instantiate those ones following your needs. I don't know, maybe you have two assets there. You have a drive which it's complex. It's a modular device which has several modules. Or let's not take a drive. Let's take a 5G modem. So you represent a 5G modem in an OPCUA model. Yeah, that's it. It's an asset itself. It has an identification. It has some firmware, maybe several types of firmwares already. It has a bridge interface, which has a number of ports. It has a Wi-Fi interface, which is respecting some standards. It has, it has a cellular interface, which respects some standards, and so on and so on. It has maybe some IP addresses, all these things. So you don't need to necessarily move all the configuration, which you have it already from the vendor in the OPCUA module. You can. It's not that you can't. You can, but it's not maybe the best wish, but you can do it, of course. It depends how far do you want to go with the specification and so on. But
I understood it. Thanks a lot. I mean, now it's much more clear. Thanks.
But careful, because you don't want always that the game here is complex, because when you do that, you need to be careful that you still need for your own company and so on to keep some added value, because if you put everything in there, then this going standardized and so on, that means everybody will have this kind of features, and everybody will do that. So
correct. Understood. Thanks.
So you define your variable, and it will end here in this section, and then you can add as many instances of it as you want in the. For example, you have I don't know, some connection board or something like that, and you have two of them, so you instantiate two, and both of them will appear here in the device section. So just as another comment is that regarding the automation world, for me, the powerful thing of OPCUA is that previously, when you go to a machine, you have to go for the documentation, see the meaning of the registers inside of and now you have a way to connect with a standard client and see the structure of the tree, data tree, and start communicating with it. And also the nodes can have a description for different languages, so you can get an understanding of what's inside, even if you don't have the documentation of the machine. You can always use this as a kind of documentation and also start communicating with it. So in terms of automation, this is also very powerful because of this, and maybe also in the network world also. And then if you go a step further, like we were talking before, and you standardize certain data types, so you will have automatic interoperability between different vendor devices. And just an example of what we did, since the OPCUA nodes can be natively, they are arrays. You can define size of array, the number of dimensions of array, and the size of each dimension. So we were testing to send images, and we created this program. Now I'm sending at 10 hertz this image. So we created this as a way of having like a standard workstation for how do you call it? Yeah, a window for the workers, for our edge applications. So we maybe have some image processing, and we can view images, and we can view real-time value of scalars. And this is a standard application that will serve the purpose for all of our edge devices. So thanks to the OPCUA standard, we can do this. And we were also doing speed tests, and yeah, we were getting like 67% of the maximum of the network. So this is more or less the overhead of the OPCUA, but I think they are great numbers. So it's a standard with a very low overhead on top of it. Yeah, so in this case we can add more, and if we have more images, we will add a different visualization for the worker. So this is just the last comments. So let's keep with the presentation. Okay, so in 2017, if I'm not wrong, they added the PubSub style communication to the standard, which is a new specification document, which I showed at the beginning in the documentation specification document list. And all that we have been talking before is the client-server model, which is a peer-to-peer communication, where, as we said, a client and a server talk directly through a set of services. And then there is this new PubSub model, where there is an intermediate network, and the server just publishes data, is not worried who is reading, and the same for the client side. It subscribes to data. It's not interested in where it's who published, or at least doesn't talk directly to them. So I did this drawing just for you to understand the different ways of communication that the OPCUA supports. So in the client-server model, we have the request-response communication, which is the one I was showing before in all the demonstration and at the beginning of the presentation, where the client requests some node or a set of nodes. This is a good thing to do instead of requesting one by one, to do all of them in a single request. This speeds up a lot the applications. And then the OPCUA responds also with a request response structure with all the information, and the communication goes on in this way. So whenever the client wants, for example, when the user presses update in the application, or maybe periodically, the OPCUA client asks and receives a response. Another way of using the client-server model is doing a subscription, which this may be a little bit confusing with the PubSub communication, but you can also do subscription with the client-server model, where the OPCUA client subscribes to the server, and the OPCUA server sends data whenever has a new update or available, or another policy we want to make in the OPCUA server. But the problem of this communication is that the client is maybe slow and cannot ingest as many data as the server produces. But a cool feature of OPCUA is that different clients can subscribe at different speeds. So, for example, even if the server updates data at 20 Hertz, for example, this is very slow client because maybe it's a small device or maybe because it is processing a lot of data. So it can subscribe to 1 Hertz, for example. And other faster client can subscribe to 10 Hertz. And the server is the one managing all of that. So, of course, this is very... what the server does is, okay, I have new data. If it passed more than 1 second, then I send to this slow client the data. If it passed more than 1/10 of a second, I send the data to another faster client. This is the best approach when you have continuous data, like the application showed. But the problem of this approach is that the more clients we have, the more operations the server is doing. So this approach doesn't scale very good. So this is one of the reasons they created the PAF-SAF communication. In the PAF-SAF communication, there is some intermediate network where the OPCUA server publishes without paying attention on who is receiving them. And then we have something similar in the OPCUA client. A client subscribes to some data or data nodes or topics in this network and doesn't worry too much if waits for the server or it is not interested who publishes. The OPCUA defines, I think, 2 networks for this implementation. One is in a local network. You could use a UDP broadcasting system, or you can have the message queue network, which would be implemented using an MQTT broker. So in this sense, this network or central element is working as a message distributor or intermediate in between the OPCUA server and the OPCUA client. And this architecture is the one that is being pushed for the cloud communications, where they are using OPCUA on top of MQTT to connect to the cloud.
One comment, one small
yeah,
comment.
please. I was going to ask maybe if you have, because I'm not very expert on this. I just did a lot of work, but in the client server only.
Yeah, exactly. So the publisher subscriber. So first of all, the communication there doesn't need to go between OPCUA client and the server for the PubSub. It goes over mostly between servers, let's say. So you have a server on the which is doing publishing, and the server which is doing subscription is just creating a sort of a channel of communication between. They are creating a connection, a PubSub connection between 2 servers. And of course, you may do lots of configuration of data and so on. I presume the best link here is to overall PubSub aspects. Let's put that in the chat. It's this one. I'm trying to put it here, and then you'll understand a little bit more how the details work. Let's say how the messages are formed, what kind of message structures do you have, what kind of payload, what kind of security you have, and so forth. So you have quite a detailed explanation here if you really want to look into that. So it's including security and authorization and all these aspects. So this is really, I would say we struggled a little bit much to do this kind of specification here. to make it a little bit clearer for all of us that how does it work and so on, right?
Thank you. I didn't know about this website. I will add all these links later to the presentation, so they are available in the final version.
Thank you, Roberto.
Because I think they are very very useful. Yeah, so in the Serious War project, since we had our OPCUA server, what we did is to use we had our cloud in Kafka, so we used a OPCUA to Kafka connector, which is a OPCUA client that just reads from the server and publishes to the Kafka system, which is I think is on top of MQTT, if I'm not wrong. I'm not a very good expert on cloud technologies. And now what we want to do in the project is also test the OPCUA PubSub and compare both in terms of performance and other parameters. So yeah, this is one of our objectives of the tasks 4.2, I think. And we will apply it also in our trial in the end, which connects to the cloud via OPCUA on top of the 5G. And we will finally try to test both ways of communication. Okay, and this is the.
Hi, sorry, on the previous slide. So I have a question.
Yes.
So I'm Shiva. So we have seen, different arguments for having, these two different models, which I understand. So if I understand correctly, so the server client model is a bit, it's not scalable, if you have quite a large number of, server clients. So we understand the fact that the PubSub model works quite well for a cloud-based communication. So my question is basically, I read somewhere that says that for an FX, OPCUA FX, the PubSub communication is preceded with the client-server model. So my question is, for example, for a C2D sort of communication, what could be the right model from your perspective? Because for the C2D, unless we run the PLC or in the cloud, like a VPLC, but if we have a hardware-based controller and device, then do you think using a client server will suffer from scalability issue? So there are a couple of questions. So what could be the right model for the FX? And then I read somewhere that for the OPCUA UAFX, the PubSub is preceded with the client server.
Preceded, what do you mean?
I can answer. May I take those answers?
Yeah, please. Yeah.
Yeah. So first of all, let's put it like that. So OPCUA FX. So again, coming back to this discussion, when we are talking C2C or C2D, means C2C means controller to controller, C2D means controller to device. The controller to controller specifications, if you go there on the reference architecture and the main link, you'll see that some of them are released, let's say, so, or at least the base ones. Now, first question, client-server communication. We did not address in OPCUA FX that one as a main target. So the first aspect which we covered was communications and creating of an OPCUA FX connection, which means two PubSub connections, because PubSub is only unidirectional PubSub connection object type. And then if you want also an answer or keep alive or something like that, connectivity, which you need very often in industrial automation, you need to have it in the reversed way too. So then we created the FX connection notion. So this is creating two PubSub connections, one in one direction, the other one in the other direction. So the client-server communication, most of us are considering it maybe less important if you have harder capabilities in the server, then you can solve the problem of the scalability and so on. That's not that issue. The issue is that client server very often is the most often what I have seen is based on TCP/IP. That means you lose a lot of time there for the TCP confirmations and acknowledgements and all this kind of stuff. PubSub is based either on datagram and on UDP where you don't need confirmation or acknowledgement, or on layer 2. That means PubSub is much more adapted for a fast communication. That means communication which needs cycle times which are under or around the millisecond level. So 2 milliseconds, 5 milliseconds, 10 milliseconds, down to microsecond level. So that's why we created the PubSub, because the client-server model was too slow, basically, way too slow. So the client-server model you can use, for example, if you read some data or you do some configuration from a PC, from a station, from somewhere where you have a client, or a human does it. But if you want to have, for example, a PLC communication or a controller communication to a device acting like a drive or like an I/O in a machine which is folding something or which is cutting something very precisely, you have no chance to do that with client server. So you need to do at least PubSub, because you need to make sure that you need to do at least let's say UDP based communication, or we call it UADP. Because we have modified a little bit the payload there. Because with acknowledgement of the client-server model, you can dream about under millisecond cycle times.
Okay, yeah, thanks. So if I understand correctly, so it's big, given the fact that the client-server model relies heavily on the TCP, which is a connection-oriented protocol, so it's not good enough for the real-time communication. So that's why we go for the UDP-based, or even if I understand correctly, the PubSub model can support the Mac as well. Yeah, that.
Yes. Yes.
Yeah. Okay. Now I can vaguely remember, because I went through a long time back. And then the second question is, so thanks for answering the first question. So I understand that it not just because the scalability is an issue, but it's mainly because of its reliance on the TCP that we go for the PubSub. Okay. So then the second question is, just for the FX communication. So in order to exchange some parameters, do we have to establish the client-server model in priori, ahead of this PubSub communication? So does it always happen, or is it not required? Through some
If you want,
yeah.
it's easier. It's an easier fruit to pick. If you want, it's an easier fruit to pick because you, for example, want to just use your equipment to read some data from it. What kind of asset number does it have? What kind of serial number you have? What is your status? All these kind of things which you don't need the microsecond level of reaction time and so on. You as a human cannot act so fast. So we are not that fast. So that's kind of the aspect. So you would need what we call the vertical communication in industrial automation. So whatever it is that the device talks to a to an industrial computer, to a mobile phone connecting to it, and so on. So whatever which doesn't need real-time communication. So because also, how does it work? So all this node set and so on. When you created all this node set and all that, you need to correlate that with your firmware. And when you are using a client and your which stays on a computer somewhere or on your mobile phone or wherever, I don't know, and it interrogates an OPCUA server lying on a device on the field, a PLC, a modem, a drive, a sensor or something, you need that sensor OPCUA server connects to the firmware and really retrieves that real information which exists there. So for the client server, you don't need a high performance internally, but in the connectivity between the OPCUA server relying on the device and the firmware of that device. But for PubSub, when you did microsecond cycle time capability, you need it. So it's an easier fruit to pick, let's say, to do a first client server implementation and then go to PubSub. Whilst it's easier, let's say, from a theoretical perspective to use only PubSub, because you can say, why should I use client server? It's doing the PubSub all the same. Like what I do with the client server. Why should I struggle even with the client server? You can go that way, but remember, the OPCUA server needs to offer the connectivity to the firmware so that you retrieve the information, you set up the information, you are reading, you are writing the information there. And if you need it fast, it needs to be doing it that fast too. So it might be that if you just are revamping an old device, you cannot do that from the first shot. So therefore, it's easier in some way to do client server. It's not mandatory on the other hand.
Okay, yeah, thank you. Yeah, cheers.
And one question from my side. So in OPCUA FX, you only use PubSub? This is or from now, yes. Okay.
For now, yes. We want to do also client server. That was always pushed because you know about the client server and TCP. It's exactly this connection orientation and this acknowledgement and all that. You need to take care of these. You need to take care of that from in the TSN perspective. Maybe later on. It's not that easy. So let's put it like that. It's not so easy to do very good quality of service for the client server model. The PubSub fits much easier, let's say, from this standardization modeling of the model. For the implementation is vice versa, I would say. But yeah.
And so in the FX, you are not doing like browse of the server or anything like that, no?
We do, obviously, but that's
you can do, okay.
Yeah, it's by definition. So if you have an OPCUA server, you can connect to it with an existing client, and you can browse the OPCUA server namespace and information model, and that's all that you can do, obviously, and you can do.
Okay. But
again, it's made for client connection, controller to controller, and then controller to device. That's why we did OPCUA FX. The connectivity to the verticals and so on, we think it's already more or less covered on various other specifications.
Yes.
And companion specs, which you have the list now, the links here.
Yeah, so my next slide was about the OPCUA FX, previously called the OPCUA over time-sensitive networks. And these are the main specifications. This 1, 2, 3, 4, 5 that we are seeing in the full list that was sent before. And what I found, because I didn't know much about the FX standard, was exactly what you commented, that the focus is on controller-to-controller communication. You say server to server, no? This is the way you look at it in your mind. Some demonstrations were already shown in different fairs in the past year, and the first release was really soon, or it was not long time ago, on November 2022.
Yeah, but the client server communication is not the main target of the FX, so it's coming. But the first release is 8089. It was client controller to controller. So basically, that's server to server, as you can see there. You may have also a client in the controller. That's true, but as you can see there, the connection, the connectivity on yellow and on blue is between server and server. So that's the point. And I would say OPCUA, with a historical perspective, OPCUA FX was called before Field Level Communication Initiative, FLC Initiative. Before it was called Shapers Initiative, until we found a place under the OPC Foundation. And it was outside of the OPC Foundation, and OPCUA over TSN. It was PubSub over TSN. That was an activity which was started in 2016, but it had, let's say, it went a little bit in parallel with the OPCUA Shapers and the other initiatives, which led to the OPCUA FX. So yeah, and it's still ongoing, that one. So it's really a little bit parallel because that is not looking to the FX. FX is adding information models over the common object types and the core object types. The OPCUA pub sub over TSN works directly to the OPCUA core object types and adds the information there.
Mm-hmm. So they are not exactly the same. That's what
No,
you say.
there is another drawing which I will try to find it where this whole aspects are shown. I'm not sure if this is public, but I'll try to find it and share a link here if it's possible.
Okay. And finally, about the 5G integration, I didn't find much. I've seen yeah, they did this alliance OPCUA Foundation and ACAI. You were, I think, talking about that before at the beginning of the presentation. And I've seen a webinar that took place on 2022. I didn't have time to see it, but maybe they explain all the alliance and also working groups that are working on integrating OPCUA and 5G. Maybe if someone knows more about this, you can comment because I am a little bit out of.
Yeah, can you hear me?
Yes.
Yeah. So yeah, I attended the workshop. I remember with the webinar, and I remember I sent some even the link videos. My impression was like, okay, this is again very personal. That what has been shown there is again very early stage, basically, of this type of integration. Again, many like at the very logical level, as you see here, and besides. Let's say the real demonstration, at least to me, looked a bit disjoint, if you want. So there were some parts that was kind of highlighted. We can understand that, of course, the demonstrations were like at the proof of concept level. So, but I would say still to reach to something end to end, there is a way to go. So yeah, we can maybe dig deeper, but yeah, this is a bit. That was my personal understanding. I don't know if other colleagues like Andre or Giovanni or Shiva would like to comment something, but my impression is like it was very early stage presentation, this webinar. Okay, I mean, yeah, but so my understanding was like, yeah, they showed something with OPCUA similar to what you showed before. So if we go back to the previous slide, the one that was with the controller to server and yeah. So they showed the same thing here, if I'm not wrong. And then if you go forward, just to show the transport layer below, kind of the one that is communicating the orders between different units. So this mobile machine and then industrial LAN, if you want. Then they used, let's say 5. But for me, it was a bit kind of still disjoint a bit. Just showing that 5G could be another alternative transport that can carry this packet type, let's say. That was my understanding. Maybe I'm wrong. Maybe I did not understood it well, but yeah. So what you
I think Pori, you're correct. So it's just connectivity by means of
exactly. It was just connectivity. Yeah.
And then but also it's not like real 5G. I would say just okay wireless.
It was only the wireless part only. Yeah.
Core
It was
network
more
was
like
to quality of service issues. You're not
exactly.
and so on. So
exactly. Just to show that probably with MIMO technology or other X technology, you can reach to latency of 1 millisecond or I don't know whatever. So I mean, we can understand it's a proof of concept. So there was no intention to showcase everything. So it's understandable. But I would say even this webinar paves the way for and highlights that there is a huge way to go and there is a lot of gaps to be fulfilled. So yeah, just to comment that.
Yeah, in the project we are going to do OPCUA on top of 5G, but yes, we are not integrating them in any way. It's just the OPCUA on top, like you said, as a wireless network. maybe this can be one of the most important jobs in the project, maybe, because I think OPCUA is incredible technology from my experience. I think it will be in the future devices. It already is although most of automation people still don't use it from my experience, at least in my region. But I think it will be the future, and I think it pays off to spend time in the project with this.
No, definitely. That's why I always try to tell to colleagues that there are some parts of the project that we can really go to trial and demonstrate them, because there is an availability of a solution already, like we can go like off the shelf. But from what I see, we are touching upon some very critical, let's say, points that maybe not everything would be product level ready, so we can do a showcase. Of course, again, we can go a bit of proof of concept, and this is the main model that we should use as in our trials. But maybe the analytic fruit of projects are also useful, because exactly we are touching upon very important gaps, and maybe this could be incorporated later on in a standard, or maybe in reference forums, and grab the attention of other relevant players, because yeah, but for sure, yeah, definitely.
Yeah, I think from this meeting, I think these are two good conclusions. No, these two gaps: one in the model of 5G parameters to the OPCUA data structure or meta model, and another is this one: how to better integrate both technologies. So I think they are. I don't know if you see anything else, but for me, are the two directions more clear from your discussions and so on.
Correct.
Yeah. Okay. Yeah, and lastly, I repeated, this is my last slide. I repeated the same slide from the previous workshop, because now maybe it has more more meaning to you, or you understand it better, no? So yeah, as we saw in the asset administration cell workshop, asset administration cell can be used for plug and produce scheme, so we can send configuration receipts through asset administration cell to our manufacturing cells or devices. And as we saw an implementation of our colleagues at IMEN that used MQTT, and when a configuration enters, they just reconfigure the software, and they show what is called, I think, operational data or output data in the OPCUA. Or you can also add some configuration that maybe the worker can change on top of this standard configuration. And we can use different protocols for each thing, or we could integrate the asset administration cell configuration in a object or a set of nodes in the OPCUA server itself. Then the configuration manager reconfigures the software and changes the structure of the server, all less this fixed part which is used for asset administration cell communication. This I think no implementation is better than the other. I think they are more or less the same, but at least we are going to discuss in the following weeks for our framework how to do it, and we will let you know. And other thing we saw is, this is not related to OPCUA, we can model at different levels. We can model our edge device that has connected more devices to it, and we can have as administration cell like a receipt to configure the devices connected here and the software blocks inside. Or we can even have more modeling, more fine grind, and model all the different devices and software blocks, and then construct an asset administration shell for a manufacturing cell, which is comprised of these smaller and interconnected assets. So since there is a OPCUA expert in the call, I will ask maybe if you have any knowledge of, because I have seen that OPCUA is working with VDMA, to standardize mostly the machine tree structure. I would like to ask if you have more information on the asset administration cell connection with OPCUA, and if you have an opinion, what's the best way to do it? Maybe I don't know if there are already some description of nodes for asset administration cell configuration, or for file transfer, or for some of this type of operation.
Okay, so at least that's not. I'm not sure this is a VDMA. Maybe it's a ZVAE specific companion specification related to OPCUA. There is something called OPCUA 3270. It's called E40 IAS specification. So I'm trying to paste also the link here with the title, and there is this kind of modeling included there. So there is a relationship with the AAS constructs. I was not personally part of this specification. I'm not part of this sub work group. Let's put it like that. But of course, if it's needed, I can ask somebody who is, and maybe we can get a presentation if you really need to look into all these details.
Yeah, because we are wondering how to integrate both. So if we can comply with some standard, or it would be much better. Otherwise, we are going to invent our own stuff.
Yeah, that should not be the case. So I'll propose you to look into this specification here. This is released, as you can see, almost 2 years ago.
Yeah, okay.
And have a look, and if this is not complete, we cannot claim this is unfortunately complete. I mean, we're never complete with anything if you think like that very absolutistically. Yeah, then of course probably needs to be added up. But I would start from this one, and I would extend this one instead of redoing something in parallel.
Yes, of course. Thank you for the information, because I was not aware of this working group also.
Yeah. And if you want to participate to working group and so on, let me know. I can ask someone in the foundation, and you can get a participation there if you believe that you have a strong opinion there and you would like this to be standardized and so on. Then obviously this should happen. But just let me know once you have looked on this.
Yeah, okay. I will look into it, because I think it doesn't fit in the general OPCUA working groups, but maybe about the data modeling, and it fits more in the asset administration cell. So yes. I will move this internally because we are really involved on asset administration cell from many years. So thank you for the information.
Yes, there are so many sub-working groups, and there is also the main working group and so on. So if this is the most interesting for you, and maybe also for the project, there are several ones as you can already discussed and so on, then let's see how we can do it further. But anyway, the base should be whatever is already released, whatever is done. Of course, it's not complete. That should be completed somehow and extended.
Okay, thank you. Yeah. And this is the last slide. It's just a link collection. I will update it later.
Just one small part from my side. If you go back to the previous slide, a minute.
Yeah, sorry.
So let's say maybe this is also, maybe we can take this for another workshop. But I think at least my understanding is like this IEC, I don't know, layer that we have, like 61499. sits on top of this OPCUA server, like on the real-time data and configuration, if I'm not wrong. So I don't know if Artur is here with us today. Okay, so probably this would be also interesting to have another workshop later on that layer to better understand those aspects too.
I think if he watches because I think he's traveling or something like that, but if he watches this workshop, many ideas may arise to him, because when I was thinking something similar to you when I was seeing at the FX, which is I was wondering, this is like with this protocol you can send workloads from maybe from one machine to another, which is similar to what 499 is doing. I was thinking, can be the 499 be on top of OPCUA FX, or I was thinking also this stuff. Yes.
Excellent. Thanks a lot. Yeah, so we will take it up with him and see how it fits. Perfect. Thanks.
So 61499 and so on, this is a little bit different modeling. Of course, you can do an OPCUA specification where you take the artifacts and the constructs of 61499 and you transform them into OPCUA object types, which extend the core object types accordingly. And then you have a specification of OPCUA for 61499. That one can imagine. I don't know if somebody has ever thought to this kind of work group or sub-work group creation, or if we believe that this is worthwhile and so on, somebody can push it and support a company who is very much into 61499, I would say. So we cannot twitter this from our side, but we have a company in the group who is. So that may be the case.
Yeah, Arthur for sure will be able to answer if it is useful or not, this work. Yeah.
Perfect. Thanks a lot. Yeah, I mean, this is also important because, like, yeah, maybe not necessarily everything needs to integrate or interact with one another. So let's see if there is any way to do so. But perfect. Yeah, I mean, very good point, and we will check. Perfect. Thanks a lot.
So we are 10 minutes away from the end of the call. From my side, I think it's okay. But if you have any more final questions, now is the moment.
No, thank you very much. But just a very small reminder that we have the work package 7 guys also waiting for us. There is an overlap. So Arturo is asking if we will finish by 12:30. So let's spend 10 minutes and then probably we need to close and we need to join the work package 7. I mean, of course, whoever is interested to join work package 7.
Yeah.
At least I need to drop out now, and maybe I will also not be able to join the work package 7 this time. I'm sorry.
No worries at all. No worries at all.
Siva has a question.
Yeah, just a quick thing. For example, say because we have different types of industrial Ethernet protocols like Class A, Class B, Class C, and for example, say Class A, like Ethernet IP users, make use of all the kind of this 5-layer or 7-layer model, all the stacks. But in the case of Profinet RP, it doesn't make use of the TCP IP, or once the frame arrives at layer 2, then it just push to the layer 7 for further processing. So it skips intermediate layers in order to bring down the jitter and latency. So given that's how it works in the case of legacy industrial Ethernet protocols, how is it going to work in the OPCUA FX? So are we going to, because I know we are going to make predominantly rely much on the TSN, so that works on the MAC layer or the the layer 2. So are we going to skip any intermediate layer? Because I understand the fact that the OPCUA works at the layer 7, it's an application layer protocol. So are we going to skip any intermediate layers in between?
Quick answer, just for now the discussions are not so advanced in the OPCUA FX networking workgroup. We have a sub workgroup called OPCUA FX networking. There the discussions are based on using or reusing whatever PubSub is offering and extending whatever PubSub is offering. I would say there is the possibility of recommending that the PubSub goes over layer 2 messages and not over UADP. For now, this is not going like that. So there is no special insistence for any of the companies doing that. So it's mostly the UADP based communication. So if this will not work, we will see. We have a prototyping working group also in the OPCUA FX. And if we end up in this working group of prototyping working group, we arrive to the conclusion that this is not fast enough, is not performant enough. UA or let's say UDP based communication for PubSub for FX, then we will concentrate more on the layer 2. But for now, this is not the case.
Okay. Another just question, just to you, Marius. So basically, based on the discussion I had earlier, my understanding is that now the main focus is on the brownfield or the rollout or whatever. So is there any effort in OPCUA Foundation to integrate the OPCUA with other legacy protocols like Profinet or EtherCAT or your main focus is on TSN?
No. Of course not. The focus, the discussion, the TSN related aspects is anyway. TSN is let's say, and those aspects are more or less optional there, so you don't need to do that. But we have already an OPCUA for Profinet specification, and I'm trying to find the right link to it.
Is it RT or IRT? Is it Class C protocol or Class B protocol?
I would say this is not at all for the isochronous communication.
It's not for isochronous. Okay.
No. This is not. This
just the real time.
This is already an old companion specification, if I can say so. So these are, let's say, done longer time ago before even PubSub has started or something like that. So this is
okay.
really, so if you want Profinet and OPCUA.
Okay, all right. Profinet RT, okay.
So it's mostly that, and I think we have the specification too. Let me try to find that.
It's okay. I saw the reference to Profinet when you were showing the kind of the documentation somewhere earlier. But anyway, it's fine.
Let me try to reach it on the current website. Second. Yeah, I'll probably need to send you somehow because it seems that it's very slow.
It's okay. That's fine. Yeah, I just wanted to check where the focus is. So now I can see, even in the past, there has been integration attempt trying to integrate to OPCUA with the legacy protocols. Yeah.
So let me try to just put it up. In a moment, you will get the link. Yeah. So.
Okay. Yeah, that's fantastic. Thank you.
OPCUA for Profinet. This is the reference, so you can open this link maybe, and then you have quite a lot of features and so on. It's about asset discovery, just read writes and so on. Yeah, some kind of module definition, some more of asset management, not the use cases of isochronous communication. Therefore, we are doing OPCUA FX.
Okay. All right. Okay. RT. Yeah. Okay. Yeah. Thanks.
This was done before PubSub was worked out, even. A little bit older already.
Okay.
Okay. The update, there is always updates. So of course, the latest release is 2021, but it was done a time ago.
Okay. All right. Thanks.
Just maybe a small comment also. I don't know if Shiva attended this session since the beginning, but it would be nice maybe later on you watch the video, the recording of the session since the beginning to better understand at what level OPCUA goes down with manipulation or modification or configuration or whatever we would name it on the transport layer. So I understand that your comments about the legacy, let's say, technologies, but let's make sure that this is done inside OPCUA framework and not through an external unit, because as far as I understood, the main objective of OPCUA so far is more monitoring the updates from the network and then do the configuration and other things through SNMP and or other network configurations outside of OPCUA. So for them, probably it's just like something already set, but we can check later on probably the recording and see if my understanding is correct. Maybe I'm wrong or so on and so forth. Okay, but let's not waste everyone's time. So what I would recommend is like probably this would be the last comment of the day. Thank you very much for all the nice, let's say, conversation that we had today. I think it's quite interesting. I'm looking forward for our meeting in Sweden so we can continue the conversation and of course update everyone else with the outcomes. Again, thank you, Roberto, for the fantastic job, for the very nice presentation, and for others, and especially Marius for all the good comments, contributions, and very insightful comments. So I would say let's maybe jump to WP7 for those who are interested / possible for them to join, because the other guys are also waiting. So thanks a lot, everyone.
Thank you
Thanks,
very
Gauri.
much.
Thank you.
Bye bye.
Thanks all.